To write 120 as a product of its prime factors, we're going to do a factor tree because these basically this divides 120 down into its component parts. So I can write 120 as 12 times 10. I can then write 12 as 6 times 2. And once I've got down to 2, that is a prime number, so I can circle it and stop there. I need to carry on with 6, but now I've got 3 and 2, so I've managed to split the 12 into 2 times 2 times 3, that's the prime factor components. I've just got to do the same for 10, so that's 2 times 5, and I've managed to break it down into prime factors. But I need to write it as a product, that means multiply together, so the final answer is 2 times 2 times 2 times 3 times 5. Note that you can check this on your calculator. You can type in 120, press equals, and then type shift fact, and that will also give you the answer, which is the same. They've just written it in index form here, but it's 2 times 2 times 2 times 3 times 5, but you must show this working. Okay, the lowest common multiple of x and 120 is 360. This is a bit of a spin on LCM because it's not asking me for the LCM, it's asking me for it's giving me the LCM and asking me for the missing number. The first thing I'm going to do is write down 120 again. It's 2 times 2 times 2 times 3 times 5. Now I'm going to think, what do we do when we want to find the LCM? Well, we basically circle, like if this was 2 times 2, then we would circle these because we don't have to account for them twice. It's this bottom one's in the 4 times table, but this is already in the 8 times table, so I don't need to deal with those 2's a second time. However, if we look at 360, what is it we multiply 120 by to give 360? It's 3, so it must be that this mystery number has a factor of 3 and then an extra factor of 3, because that means when I find the LCM, I can circle this one. Okay, so I only deal with this once, this 3, but then I would multiply by the 2, 2, 2, and this 3, then 5, then this extra 3, and that's going to be what makes it come up to 360. So actually that is the answer. The answer is going to be 9, because basically what do I have that's extra? I need an extra factor of 3. So I've got to add that in, here it is, but I need the original factor of 3, because if it was just 3 by itself, then the lowest common multiple would be 120, because 3 goes into 120. So I need this extra one. And because it's asked me for the smallest possible value, I don't want to add any extra ones here, like a 2. Okay, 18 would also give me a lowest common multiple of 360, but 9 is smaller. For me, that is an awkward question. Okay, back to finding HCF, and now we're given the numbers to start with. So A is 2 to the 4. I'm going to write this out in full. 2 times 2 times 2 times 2 times 3 times 3 times 7 over here. I'm going to leave a bit of a gap. And then B is 2 times 2 times 2 times 3 times 5 times 7. Now HCF is the highest common factor. It's the highest number that goes into each one. So now I'm going to circle. So I know that 2 goes into both of them, but then 2 goes into both of them again, and then again. I don't circle that one because 2 doesn't go into B 4th time, but 3 goes into both of them, and then 7 goes into both of them. So that is it. And actually you can get it by looking at this. You'd see that 2 to the 3 goes into both, then 3 goes into both, then 7 goes into both. It's the same idea. I decided to write out in full. But our answer is going to be, we're going to multiply these pairs together. 2 times 2 times 2 times 3 times 7. And let's work that out. That is going to be, it's going to be 2 times 2 times 2 is 8. 8 times 3 times 7, which is 168, and that is the HCF of these numbers. So they've done the hard bit. Well, not the hard bit, but the bit that takes a fair bit of time, writing it as prime product of prime factors for us in index notation. I have expanded it. You don't have to do that, but we've looked for the pairs and we've seen that 168 is the highest common factor.